Meeting is being recorded.
So, hello everyone, good morning and afternoon. Welcome to VizConnect, connecting people with the art of data visualization and storytelling. My name is Sagar Kapoor and I'm a part of customer success team at Tableau. So today we have someone special at VizConnect. He's a Tableau Zen Master and the Alteryx ACE, and he will present his look at a common mistakes in data analysis using examples from politics, marketing, as well as real life data sets from business, and give us tips on how to avoid having your visualization labeled as fake news. And the fun fact about him is that data analysis has directly helped him to drive Lamborghinis in Las Vegas and flying a plane in dogfight over New York State. Everyone, please welcome Chris Love. Over to you, Chris.
Thank you very much. Hello, everyone. Good morning or good afternoon. I want to start the talk today by talking to you about kind of the reason that I'm doing this and the inspiration for talking about this subject, which is how to handle data with care. What I was at what's called a BI Bake-Off in London. I was invited to represent Tableau. This is me presenting my final viz, and the premise of the evening was to show the capabilities of each tool, and for three data experts in each of the three tools to talk about to build a viz. If you've seen Iron Viz, then it was very much like that. So that the premise was to build that visualization in 20 minutes and then present it back to the audience. This is me doing mine. And each of the other presenters presented Power BI and Click. And we were all experts in data visualization, presenting tools that we knew very well. And one of the presenters presented this. And the story was about gaming and e-games. And what this shows is how the males and females percentage in the gaming industry has got closer and closer over time. And the presenter talked about how that was represented in the data, and talked about a story that picked that up through the other data in e-gaming. And I was looking at this and I realized that there was a mistake on the chart. Now, as you can see, if I just use my mouse to highlight kind of some of the years, the axis doesn't represent years chronologically. It's actually just sorted by the number of females in gaming, sorted in an ascending manner, which means that, of course, it tells that story that the presenter was telling us. So I really took something away from this. This was three presenters who are skilled in data visualization. And it shows that it's possible for anybody to make a mistake. Sorting the data like this and telling a story when you've only got 20 minutes is something that's bound to happen. I don't blame the presenter. This is something that when you're under pressure can obviously happen. And if under that pressure, then it's very easy to make mistakes. But if three experts can't tell a story that holds up, then I'm worried for the future of our careers. So that was the inspiration for this talk, really. So that was really the driver for this chart. So who am I? As per the introduction, a very nice introduction, I'm a Tableau Zen Master. I'm an Alteryx Ace. I work out of the UK. I'm based in Nottingham and work out of London as well. So I've been using Tableau for 6 years now. I found Tableau when I was working with Alteryx. I started using it in my bedroom, started using Tableau Public in my spare time, blogging on it, and then was lucky enough to find a job with the Information Lab. And since then, I've become a Tableau Zen Master. And it's a real privilege to talk about Tableau all around the world, going to conferences and things. So thank you for having me. I wanted to start off this talk by talking about going back to basics, a data visualization 101, if you will, and talk about why we visualize data. I'm going to start with this video. This is on on pre-attentive processing. It's something you can find. I'm going to ask you to find the outlier. So you'll see a set of circles and they're going to flash very, very quickly on the screen. Then I'm going to ask you a question about them afterwards. Here we go. So hopefully you saw the red circle amongst those blue dots. It flashed up for a 1/12 of a second, but your brain was still quick enough to pick up that change in colour. And we're going to have another scene next that's going to do a very similar thing. And I'll ask you a question afterwards. So again, it's going to flash up very quickly. You're going to get a fraction of a second, but I want you to see if you can see it. That was a lot harder to see. There was a red square amongst those green, those red circles. I'll probably stop it there. There's another example, but this was just a very quick demonstration of what we call pre-attentive attributes in data. Pre-attentive attributes are the things that help us decode data very, very quickly. They're the innate ability of our brains to understand things visually. I want to give you a definition of what data visualization is and visual analytics. So Andy Kirk, who's the author of Data Visualization, says that visual analytics is the representation and presentation of data that exploits our visual perception abilities in order to amplify cognition. Let's break that down. So Andy's saying that visual analytics exploits our visual perception abilities. So it exploits those native abilities that we just saw in action when it was really easy to see that red circle amongst the blue ones versus the squares, versus the red square in the red circles. So visual analytics, when we do it well, should exploit those visual perception abilities. We should use things like color over things like shape because it immediately stands out. Our brain can immediately understand it. And so we represent data and present data in a way that exploits those systems in our brain. And importantly, we do it in order to amplify cognition. We do it to give our audience more understanding of data. Tableau's mission is to see and help people see and understand data. This is exactly the same thing. So this is what Andy's saying. We need to exploit those visual perception abilities in order to amplify cognition. Let me give you another example. How many 9s in this image? It's really difficult to do. It's really difficult to pick out those 9s. How about I use our visual perception abilities, those pre-attentive attributes I talked about, to make it a little bit easier. Those pre-attentive attributes make the data stand out and make it really easy to count. There are 10 9s. That is pre-attentive attributes at work. We're faster when we can see data because of those pre-attentive attributes. If I ask you to find the lowest number in this table, then you're going to spend a while looking for it. Perhaps your eye will be drawn to this row eventually and you'll spot it just here. 43,000. What about if I used color to highlight that? Now what if I use length on those bars to visualize the scale of that change, of that of those sales? The length on the bar and the color now stand out, and we can immediately spot that tables in the home office segment are the lowest. This is pre-attentive attributes and visual analytics in action. So pre-attentive visual attributes are things like length, width, color, size, shape. These are all things we're familiar with when we use Tableau. And there's a reason they're on that attributes shelf, the mark shelf in Tableau. It's because these are great things for calling attention to our audience and discerning the data. So how should we use these pre-attentive attributes? Well, we need to realize when we're using them that some are more important than others, as that video right at the start demonstrated. So position on a page is by far the most important when it comes to these pre-attentive attributes. If we've got something that we're displaying, then we want to use position to show it, because our audience will notice that position a lot quicker than anything else. Then, as the video demonstrated, color really stands out. So we should use that next to demonstrate to our audience what we want them to see. The size, and finally the shape, is the least important. Again, as the video showed, it was really hard to pick out that red square amongst the red circles. Let me show you an example of this. So here we have two products. We have, let's say, sales information about them. And we're just looking very quickly at three different ways of presenting this data. So at the top, it's very easy to see that product A is about 1.5 times bigger than product B. It's a lot harder to do that with the circles at the bottom right. I can't say for certain this is definitely 1.5 times bigger than this. And I certainly can't say that this color is 1.5 times darker than this color. And Steve Wexler talked about this at the Tableau Berlin conference and the Tableau Las Vegas conference recently. And this was an example he shared, and it really resonated with me because this really helps stand out where the differences are in these pre-attentive attributes and why color isn't as good as showing these differences as things like the length of a bar chart or the position on a page. So with that in mind, and thinking about why we visualize data in the way we do, then we can start to look at examples of how to spot mistakes or problems with charts and how not to do it yourself. Or, as I've called it here, how to lie with charts. I don't think we should ever lie with charts to help our point. What we should be doing is being able to spot when we've accidentally used charts to mislead our audience, and others have, in order to fix those. So here's one example. Let's tell you a story about this data. So this is some sales data, and the marketing person has just done a campaign, and they've come into the room with this data, and the marketing person is very pleased because it's a campaign that started back in February and it's now December. And as you can see, since February, sales have been rising very steadily all the way up till to this point in February. And so, you know, they're going into the meeting reasonably happy with the job they've done, and they're likely to be perhaps looking for a promotion or looking for congratulations from their colleagues when they share this chart. But there's a problem. Let's take a different look at the data. This is what we're calling selective framing. The marketing person in this case has picked a particular view of the data that helps tell their story. And if we zoom out, then you can see that actually the period changes every February to December. And they've just selected the most recent year in order to tell their story. And yes, this year was a little bit better, but put in this context, we can see that it's not all down to that marketing campaign that they ran. It's actually just a cyclic piece of data. And this is something that we often see in real life, in journalistic tweets and things that selectively frame data in order to give us the view that the individuals want us to see. So this is an example from Fox News, and it shows that I think 1.4% of annual economic growth in the period 2009 to 2016, whereas during the previous 1950 to 2008, it was much higher, and this was something that was used to bash Barack Obama when he was in office. Talking, why is the annual economic growth when Barack Obama's in office so much lower than the rest of the time? And again, this is because of that selective framing. We've picked a time frame that helps tell that story. And if we look at the data, then we can see the period we were looking at just here. It's just at the very end of a long downward spike. And actually, there were times when it was much lower during this. But if we take the average of this period, it's going to be much higher than the average of this short period because we've got lots of these high values right at the start of the time period. So that's not a good way to tell a data story, and we should be very careful when we selectively frame data in our presentations that we don't do things like this. Another example, here we have some sales data again, and we're looking at the office supplies. The office supplies are obviously not doing very well compared to our other markets. We might use this to perhaps push for more investment in office supplies, or perhaps to get that range removed from our superstore totally. However, when we look at that data in context, then we realize that what the author of this chart has done is actually shorten the axes. They've taken advantage of those those pre-attentive attributes that I was talking about, which are length, and the length really stands out, and we automatically interpret this length to be, well, 1/20th of the length of this much higher chart. And so we frame that in our minds as office supplies being 1/20th as bad as technology. Whereas what we can see when we look at the data in its full context with the full axes on it is that we have much closer sales than we perhaps expected. So again, this isn't a good thing to do. There are lots of times where you shouldn't use a zero axis, but certainly with bar charts, if you're unsure, it's almost always the answer is to keep them at starting at zero. Here's an example from the UK, from election leaflets. We had an election just yesterday. I think this was from 2005, this election. And you can see that the Liberal Democrat leaflet have shrunk that Conservative vote to much lower. It's actually 4,500, so it should be somewhere up around here. But the election leaflet wants you to vote for the Liberal Democrats and believe that the Conservatives don't have a chance. So they're presenting that data in a way that favours them. They're using data to tell lies. A third example, this is one of my favourite ones. So here we're telling the story. We can see that both axes start at zero, so we're on a good line. This is a dual axis chart, and you can see that our orange sales have been rising from 2015 to 2018, but our profit has barely risen. So this is perhaps not a good news story for our company. Perhaps we need to do something, and this is a chart that could be used to sell that story that perhaps profit isn't going as well as we think it is. But what if I tell you another story? Again, both axes start at zero. Now with this chart, I can tell you that both sales and profit have risen at exactly the same rate. Everything's going really well, and our company's in great shape. It's the same data. Everything starts at zero, so we're not using our axes to tell lies. But what we are doing is mixing our our dual axes in order to present the story as we see fit. And this is really hard to get right with dual axes charts. Dual axes charts mean that we've got to decide somehow how to frame these two lines against each other in order to present the story. And that means that you're somehow having to get them to cross at places which the audience can infer things from, or you're going to have to get them to do things in different ways, that perhaps with different gradients. Here's another way of telling a story. Profit sales have rocketed. Profit is just going to the same place, and soon sales will overtake profit. It's the same data. It's a different story that you immediately see from this graph. A better way of telling this story then, in order to fix this, is to use what's called a connected scatter plot. So here we're looking at 2015 to 2018, and we can see that both profit and sales have started off low. Sales dipped slightly in 2016, while profit continued to rise, before both of them continued to take off. So that's a much better way of looking at the data and helps us to view that data in a more trustworthy way. Likewise, we can index our sales. We can use a percentage change since 2015 to look at the percentage change in profit versus sales. And what we see is that the percentage change in profit has risen over almost 90% in that 4-year period, whereas sales have gone up to just over 50%. This was something that we didn't get from that first, if I just go back, that one, we didn't get that from this chart. We didn't see that the percentage, that profit had done this well compared to sales. That's why dual axes charts need very careful consideration if we're going to use them. And it's another way that you could potentially lie with data if you're not careful. Another example is spurious correlations. So saying two things are related when they're not necessarily related, and we've got no proof that they're related. So this is a chart. I forget where it's from, but it's showing the US unemployment rate versus Hillary Clinton's approval rate. So a relatively old chart from before the US election 4 years ago. And it shows the US employment rate falling at exactly the same rate as Hillary Clinton's approval rate, which means that we can start in our heads to think that Hillary Clinton is somehow causing the US unemployment rate to fall. And you've got to be really careful when you make those spurious those correlations. You've got to check that one thing is actually causing the other. Correlation isn't causation. Another example. I think this is the last one. So we're what I call ignoring other factors. So here we're looking at the most dangerous cities in the US. So again, oldish data, 2014. This shows that Chicago is quite a dangerous city to be in. 407 murders in 2014 versus New York, Detroit, Los Angeles, and Philadelphia. And you might look at this and worry that Chicago is not a place you should visit. But if we bring in the other factors, in this case, the population of Chicago, New York, Detroit, etc., then we can see that in murders per 100,000 people, quite a depressing topic for a Friday afternoon, but Detroit has a much higher per capita murder rate than Chicago. In fact, Chicago doesn't feature on this new chart. And this is obviously something that matters a lot more if you're going to visit these cities. Rather than the total number of murders, it actually matters how likely you are to be involved in them. I've got a couple of examples from last night's election here in the UK as well that I dropped in this morning, because I thought it was really interesting to see the news presented back and data visualization taking such a prominent part of that news coverage. Andy Cockgreave, Tableau evangelist and all-round data guru, was tweeting these out on the elections viz hashtag on Twitter, and I was following along till the early hours of this morning, chatting about the different data visualizations that were on our screens in the UK. And these are a couple that Andy picked out. So comparing Brexit vote by party, which is the easiest to read? Here we have 4 different pie charts representing the 4 of the different parties in the UK, and we can see their main votes in the EU election highlighted with the blue bars versus the bar charts on the bottom show exactly the same thing. So which is easier to see at a glance if you're telling this story? Again, our visual perception, those pre-attentive attributes that I talked about, we talked about length being the best one to use. And therefore, if you've got to tell a story quickly, use the length and a simple bar chart to tell it, because our eyes just don't work in these circular, angular ways in exactly the same way. That's not how our brains evolved with these pre-attentive attributes, and therefore it takes us a lot longer to interpret these different bars and to see the different who's higher. It's only a fraction of a second, but if you're telling your audience a story through journalism or in presentations through your when you're going about your jobs, then it's really important to tell the story as quickly as possible. Here's another chart that was shared. This is the change in share in a particular constituency. So we can see that the Conservative vote rose 2%, the Labour vote fell about 13%, and the Brexit vote, party vote, rose about 11.6% in this particular constituency. And as Andy asks, he says, where is the data point? When we're comparing these charts, where should we look for the data point? And that really matters when we come down here, because with the Lib Dem versus Green vote, we can see if we use the top of the arrow, the Lib Dem vote looks about what, let's say 1.5 times, perhaps just a little bit less of the Green vote, whereas we can actually see it was nearly 3 times bigger. So the data point itself, we should be comparing the top of this bar just here without the arrow to this one just here. And as our eyes use that length to compare these values, they're going to jump to conclusions like that and tell their own story despite the numbers that we see down here, because that's what our brains do. They use these visual attributes to make snap decisions, and then we have to talk ourselves out of it if we want to understand it. This particular example was from Sky News. So drop in visual features like arrows on top of our bar charts. If you want to understand your data quickly, your audience to understand your data quickly, then it's really important to think about decisions like that might make things look prettier, but don't necessarily help your audience understand things. I want to move on to a worked example of how I've fallen into this trap of around critical data analysis, where I've had to be critical of myself in using data and understanding it. So this example came from a Makeover Monday problem, and if you follow Andy Kriebel and Eva Murray on Twitter, or their Makeover Monday project on makeovermonday.co.uk, then you'll know that Makeover Monday is a shared data set that gets shared every Monday. It's presented to the community in the form of a chart that's maybe been put into the press or shared in newspapers or reports. And Andy and Eva invite you to remake that chart using the data set and give your own take on the story that's told. Can you tell the story better? Can you tell a slightly different story? And Makeover Monday is a great way to practice your data skills, to try telling those stories, to try building these charts and see if when you post it to Twitter, people understand it in the same way that you think they might do. It's also a great way to practice your Tableau skills. And this particular example was on the land use per gram of protein by different food types. So you can see from the original visualization that was shared that beef and mutton use about 1 square meter of land for every gram of protein that we get from our food, whereas pork, fresh produce, poultry, eggs, all the way down to pulses are a lot lower. So pulses, you can get much more land to grow 1 gram of protein than you do from using beef or mutton, cows grazing on that land. And that in the sense of climate change and the conversations that we're having about the world today, that's a really important thing to discuss. And you can see the data set was a very simple one. So it just contained the different types and the land used. And it would the metric that this is presented in is meters squared per gram of protein. And so I was thinking about this for Makeover Monday, and I came up with this visualization. So these are meters squared. So in my head, I thought I need to square the data, and then I can present the land use, because we're comparing meters squared, so 1 meter squared versus all these, and you can immediately see just how many pulses you could have got into each of these, into this 1 gram, this area used for 1 gram of protein. And I then turn this into, if we use 1 bean for 1 gram of protein, how many grams of protein could we grow on the land of beef and mutton, dairy, etc. So again, presenting this in a way that told a story, you had to scroll to the right to see just how many beans you could have planted on that one area of beef and mutton. And I shared this on Twitter, talked about it on Makeover Monday, and I was relatively happy with myself, but I'd made a mistake. I'd interpreted the units wrong. I'd interpreted the fact that meters squared meant I needed to square the meters in order to get to an area. That wasn't the case, and I'll explain how I found that mistake in a moment. Other people were making mistakes with the data too. So some people took the land use and divided it up and said, well, 88% of land use goes towards making food for animals. And that's not the case. That assumes that the land we use for each of those different products is exactly the same across the whole world, and that's not the case at all. Likewise, beef mutton land use is 77% of Central Park. I don't think we can say that from the data we've been given. We've only got the data that shows us 1 gram of protein versus across all these different food types. We can't say for sure how much land use is used for beef and mutton from that data set. And again, a different way of looking at there, breaking up the land use by these percentages. So everyone was making mistakes with this data set, and I wonder why. Why are people making these mistakes with what should be such a simple data set? And again, another take just there. So if you're going to analyze any data, and when you see stories presented through the press, or you're doing something yourself, it is very easy to have mistakes. That mistake that formed the basis of this whole talk in that competition that I talked around at the start. We need to critically evaluate them. And so one way, I'll share several ways of doing this. The first tip I've got when you're evaluating this is, does the data result in sensible numbers? And so what I did was, when I was thinking critically about what I'd just done in terms of squaring that land, I thought about, well, what does that mean? So if I square the meter just here, then I can fit 9,254 beans in 1 square meter, versus if I don't square it, I can fit 96 of these. Now, I'd done this one. This was the data in the raw value, and so if we assume that square meters are a quarter protein, pulses are a quarter protein, then using this data, then I can work out that we get about 400 grams of pulses grown per square meter. And if we use this one, then I can work out that we get about 9 kilograms of protein, or 4 kilograms of pulses per square meter. Now, getting 4 kilograms of pulses from a square meter of land through farming is some incredible farming. And I don't think I'm no expert on pulse farming, bean farming, but that seems incredible to me. So I think just running some rudimentary numbers, looking on Google about the amount of protein per pulse and doing these calculations just helped me to visualize, actually, am I telling the right story here? What is this square meter thing that I'm visualizing, and what's the right way of interpreting it? And then I started digging further into the data, because I was really intrigued by this data set now. Where did this square meter squared thing that I'd misinterpreted, that it's really easy to misinterpret, where had that come from, and what was the source of this data? The data itself was from a paper, an academic paper, which in itself is a good place to look, but it was a metadata study of lots and lots of different studies into the land use for different food types, and they'd aggregated all that data. And so then we can ask ourselves, what happened to that data when they took all those different studies and pulled them together for this academic paper? How did they treat that data? Did they talk about their methodology? Can I replicate it? Is it reliable? And that's what whenever you receive data in a business world or in your private life on the news, you need to think, how was this data treated? Who treated it? And what is their aim? What is their objectives in presenting this data to me? We need to be critical and say, can I trust this? And so in this example, they took different data sets. So in this case, they took a data set from this Wiedemann, and they looked at different meter squared per kilogram of food for different types of feed for cattle, and converted it to meter squared per gram of retail cut. So Clark and Tillman seems to have converted this to 13% of protein per retail cut. And then in another paper that they used, this was presented with a similar comparison of meter squared per kilogram, but they used live beef weight. So rather than per retail cut, rather than taking 13% protein per retail cut, they've taken 5% of protein per live weight. Now, is that right? I don't know, but it seems a very rough way of working things out. I don't know if that's fair, but it starts to make me ask questions about how they've taken the data from these different studies and brought them together. They've got different people doing different studies on different things, live weight and retail cut, and they're trying to bring them together into the same measure. So we can start asking questions. How crude are those measures of meter squared per kilogram? What potential error margin can we attribute to them? the original studies must have had error margin. Have we discussed those in this master paper that's brought them together? And is that error being communicated to the end user? Because they've taken all these measures and just combined them into one value for each food type. For the beef, we have one value that we compare. From all these different studies, is that fair? And so we can say those aggregation methods that were used to represent the data when they took all these different studies, how have they done that? And does it represent the data well? So I dug down right into all this metadata study and found all the different grams, the proteins per gram that each study shared. And I looked and charted each of those different values. And you can see that from the circles plotted on here. And then the average was what the study picked out. So the study picked out the mean value from each of those metadata and from this metadata analysis of all those different studies, and it picked it out. So you can see from the bars, this bar just here represents the range of the data and the interquartile range, and this is the median. So the median value of fresh produce is a lot lower than the mean value. Is a mean value the right way of interpreting this data, or is mean a fairer way? You can see that for wheat, we've got these big outliers up here. Is that fair to use the mean to represent this data, or should we, with all those outliers, have used the median? Likewise, fresh produce has got this one outlier, this one study that showed it was 1.2 meters squared per gram of protein. That's brought this average right up here versus the median that's down here that might be better representative of the overall data. And I've had to put beef on a different axis, but you can see we've got the same problem. The majority of data is clustered around these really low values. The value that was presented in the study is a lot higher, and it's brought out by these big outliers. Now, I don't know enough to criticize this paper and say that the mean and that they didn't treat the data well. But when we critically evaluate and ask ourselves questions, we get to a very different point in our heads about whether we can trust this one measure that we've been given for Makeover Monday and how we present that back to our users. We are critically analysing what we're doing and talking about, is this a measure I can trust, and is this a measure I should be using to talk about my data story? This is what we need to do more of in our business world. We need to critically evaluate the data sources we're given. We need to do this for political data. We need to do this whenever we're given data. Here's another way of looking at this, the median versus the mean. The median was a lot lower and could have been a lot more representative of that data. So I asked myself, does the mean truly represent this data? Is the median a better measure due to the skew? Are the above issues important to our story and audience, and do they risk the legitimacy of the data we're presenting? And should I show the margin of error in that data as well and the range that we've got? All these questions, if I was presenting this now, are things that I think about. Finally, why are we using this measure? Is this a measure that even makes sense to our audience? Meter squared land use per gram of protein. The studies also offered meter squared per calorie or meter squared per gram. The authors chose to do it per gram of protein. Does that make sense? Is protein something I think about when I eat? Is it a natural measure our audience will understand? Again, making those decisions when we're presenting data are really key to understanding things and telling a good critical data story. So that was my journey through a critical piece of data analysis. It was looking at some data and really thinking about what what had I done wrong? How could I have better presented this? And going down the rabbit hole of really looking at the data set. I'm going to very briefly talk about patterns as well, because this is something else that you need to be aware of. This is a tweet from my colleague Jonathan Allenby. He's in our data school in London. Jonathan says, for this particular Makeover Monday story, he's presented the data, and he says there must be a story for those energy spikes in January and February, so these ones. But he's not sure how, where, if he can explain why these patterns are happening. And that's a really interesting comment. He's seen a pattern in the data but can't explain it, but knows there must be a story there. It's something that we're really keen to do. We're really keen to spot these patterns and explain them and use them to bash people with, particularly if it's news data. Here's a news story. 10% of Somerset schools are well below average. Of course they're well below average. This is 10% of schools have got to be well below average, because the average is halfway point. It's the mean of all those schools. So of course some of them are going to be below average. But the media bashes us on this pattern that they see. And Jonathan could be making the same mistake here. He could be start bashing Downing Street for what is perhaps a natural occurrence or a random piece of data. Here's some data to illustrate that. Surgeons in a hospital performing an operation, and how many complications do they have from that day, from this operation? Well, we see that Surgeon A is certainly not someone I trust to do my operation, because he has lots and lots of complications for this one piece of surgery that's exactly that all these surgeons are doing. Is this fair then? Should we be firing Surgeon A? Well, let's look at the data in terms of the rate of complications. And we see that Surgeon A is still doing fairly bad, but not as bad as we thought. On the previous chart, Surgeon C didn't look like one of the best surgeons, but we actually see his rate of complications is still quite high. And then you think, well, still, Surgeon A could presumably learn a lot from Surgeon C. We still got a difference of nearly 3% in the number of complications. So surely there's something he could learn from. But then we realized that actually this data is random. What I've done is just generated a set of operations and given each surgeon exactly the same chance of failing at that surgery. I've randomly generated the data and then I've plotted it. So while I can tell myself a story about Surgeon A and Surgeon C or Surgeon F, it's not actually true. This is just a random occurrence. And we see it all the time. We see footballers who go on goal streaks or goal droughts, and the press say he's lost his edge. He's not scoring goals anymore, when really it's just a random chance of not scoring goals in a given game. And those can add together. Another one, perhaps bicycle failures. Across time, we can see that there were a lot of bicycle failures in this particular time. Again, I've just randomized the data. This is a random chance that we could start investigating these failures. And it's really easy to do. This is a Makeover Monday. A similar kind of story, trying to tell ourselves stories about patterns we see. London buses are more dangerous for women because, look, they have more accidents. They're involved in more different injury types. Less assault, more onboard injuries. Perhaps we need to make buses better for women so that, one person actually commented on this and said, maybe it's women wearing high heels on the buses, and that's causing them to fall over. Southern buses are particularly bad. Maybe they've got bus floors that aren't high heel friendly or something. No, it's just that more women are riding the buses. Women use more public transport in London because of the nature of their day. Therefore, they are more likely to be in this data set and having accidents. We can tell ourselves, but we need to be careful of the stories we're telling and that we critically evaluate the data. Likewise, from the same data set, this is looking for patterns on incidents causing injury and looking for peaks. And we can say, Westminster, Redbridge, what happened here across these times that there were these little peaks? Maybe we need to investigate them. I say this is highlighting patterns that could be random. We need to be really careful about saying we found a story in the data if we're just looking at patterns that could be random. We need data to make more data to make more sense of this. So I'm going to finish with my tips. After all those different examples, my tips for responsible data analysis. Be insatiably curious. Don't be afraid to dive right into data sets. Ask yourself questions about them, like I did on the grams per protein example. I went into enormous detail on that grams per protein, but I think it's a fabulous example of what a simple data set looks like that actually is a lot more complicated under the scenes when you dive right into it. Practice, practice, practice. Makeover Monday. Iron Quest run by Sarah Bartlett. There's lots of ways of practicing telling data stories. Use them because it's much better to make mistakes in public in a safe environment like Twitter than it is in private back at your job where people might not spot them, which have much bigger consequences. Don't trust anything. Be insatiably curious, but don't trust anything. If you're given some data, ask yourself, what is this data telling me? Why should I trust it? And what's it done to deserve my trust? How was it created? Things to understand when you get a new data set. Understand what a row is. Where's it come from? What's the overall population, like that London bus example? Am I being given just incidents? What's the overall population of those incidents? And what's the context of them, of how the data was created? And finally, common myths. A myth is that talking about limitations in data sets limits the power of the analysis that you're doing. If you somehow shine a light on the data set that you're using and talk about its limitations, are we undoing all the work that we then do in analysing that data? No, you're not. You're not, because talking about those limitations shows that you've thought about the process. It shows that you've thought about it and how then demonstrates the value of your later analytics. Another myth, analysis happens after you have the data. It doesn't. Analysis happens almost while you're collecting the data. Before you've got the data, think about what it's going to show you so you can get a good data set. And finally, the more complicated analysis is, the better it is. And that's wrong. We don't need complicated Sankey charts and complicated visuals in order to tell a good data story. This is something I see all the time on Twitter. Complicated charts do not make better analysis. We can tell good stories with simple charts. Your story is only as good as your data, and it doesn't have to be complicated. That is me done. I want to thank you for listening and just give you the opportunity to take any questions. Thank you.
Thanks a lot, Chris. I think thanks a lot for sharing those stories and tips and tricks. I think we have just 7 minutes. So if anyone has any question, go ahead, just put it into comments or Q&A tab, and Chris will love to answer all your questions. So Chris, maybe I can start with a question. So maybe can you tell us what are the 3 to 4 important things if someone is just starting with Tableau, or maybe starting, what will be the 4 advice you will give it to them?
I definitely say when you get a data set and you start analyzing it in Tableau, understand, I think I said it in this one, understand what a row is. When you drag that sum of number of records onto the pane, what is that counting? Is it counting the number of sales of something, or is it counting the number of sales, or is it breaking down the number of items that were in a particular sale? Because they're very different things that we need to understand in different ways. So understand what a row is the first one. Understand what blue and green in Tableau mean. Continuous and discrete variables. Drag them onto the pane, see what they do. Green pills can create continuous axes. Blue pills create discrete labels. They're very different things, and there's plenty of blog posts out there that help you understand what those things do. Take time to understand what Tableau is doing. I've got a presentation on I presented it at the Berlin Tableau conference called When Tableau Breaks. You can find that on YouTube. Use that to understand what Tableau is doing underneath the scenes of when you drag things on. What does ATTR mean, etc. Understand Tableau, then you'll be able to do your analysis much better. Do we have any other questions? I think
And
I've
sorry, Chris, I think I was dropped out. I think we have
okay.
just, yeah, but let me just check. So I think there was one more question on if you are basically going ahead and telling a story of storytelling with data, right? So what will be your tips and tricks on that? Any inspiration you feel they can go ahead and follow, or any books you want to recommend?
Um, yeah, storytelling with data is a difficult one. I think consider your audience would be my first tip on that. What does your audience want to get out of your story? What is the story you're trying to tell with data? Um, if you don't know that and you haven't thought about what your audience will find interesting, you run the risk of telling a story that is essentially given away in your title, and that the audience never looks at the charts, never goes any further than where you than what you're presenting. A lot of the data sets I see on Twitter are relatively uninteresting. Share some interesting data and then form a story around that. Take your user on a journey through that data. In terms of books, in order to tell data stories, I think Info We Trust by RJ Andrews is a really good book to understand the world of storytelling and the world of data, and Storytelling with Data as well, by Cole Nessenbauer is um, a wonderful book that helps you just frame those charts and tell stories with them. So definitely, and Cole's got a new book called Let's Practice as well, that I haven't read, but I've seen recommendations, that is another good way of working out how to tell stories. But again, practice, ask people. That the only way you get good at data analysis, it's the way I've got good, is by practicing.
Okay, I have just one last question for you. So someone has asked if basically they are working in a financial industry, right?
Mm-hmm.
So I think in finance, we just have cross tabs and just tables and all, right? So what will be your feedback or advice for them when they're representing something in a data visualization tool?
I think it's I get that feedback a lot. You know, accountants and the financial industry just need tables and just need to see the numbers, and that's right. They do, and it can be a long journey to take someone who's used to looking at detailed spreadsheets into the visual world. I'd say don't rush your users. You know, if you're very evangelical about this, you can come across as not listening to your audience. Your audience is always right in terms of what they want to see. They might be misguided in that, but they might not appreciate the options. But if they want a table, then don't think you can be that evangelical and not give them it. What you can do is show them other options, though. So of the best techniques I've used to get around those arguments is to share the data, but then on another tab present something that shows, as I was showing at the start in that data visualization 101, uses lengths, uses color to try and highlight things. One of the quickest ways of showing changing a table of numbers is just by using a heat map with it. Put color behind the cells to show the biggest and smallest values. That means that you're subtly guiding your audience on this journey of visual analytics. Next time you might include bars just to show them which is the smallest. Educate them on why data visualization is important and give them charts that help them do that. But don't expect your audience to move suddenly into wanting big, extravagant dashboards. Just because you find them useful doesn't mean that everyone will.
Thanks a lot, Chris. I think it was a pleasure to have on VizConnect. Thanks for all the information and great examples and some great tips and tricks. So I think I will go ahead and share your session on the YouTube so that people can go ahead and watch it later. But thank you.
problem. Thank you for having me.
Perfect. I think have a great weekend ahead.
You too. Thank you very much.
Happy holidays and a Merry Christmas to you. Thank you.
Merry Christmas to you. Thank you. Bye-bye.
Bye-bye. Take care.